Hello and welcome. My name is Ivan Ferraud and I'm Technical Director here at Pharma Technology. Today I would like to introduce you the iSpray, which is our latest machine and is a punch-face lubrication system for tablet presses. First of all, in which cases should we use such a machine? For example, if you have sticking, capping, or if you have too high ejection force, maybe you have chemical incompatibility between the lubricants and the composition of your formulation, and of course also in continuous manufacturing lines. What are the key benefits of this iSpray machine? Well, first of all, we have our very own high under pressure vacuum system, making sure that we always vacuum the excess lubricant that goes into the press, avoiding therefore the recirculation of the lubricant. We also have the flow measuring device, which allows us to control via our software the amount of lubricant going into the pipes and therefore to the spray nozzle. Then we also have a backup line system with two venturis, one which is working and the other one waiting for the first one to go in default, automatically switching from one to the other via our pressure monitoring system. And finally, as you can see, we have a very easy to clean machine. All the components can be removed without any tools. So let's go over the process of the machine. First of all, the lubricant is fed to the machine in bulk and then goes to the hopper. You have precision dosing system with a screw, and then you arrive into a smaller hopper, allowing you to either go to side 1 or 2, depending on which one is being used currently. As you can see, we have also pinch valves up and down from the venturis, allowing you during process, without stopping anything, to remove one of the venturis, isolate it, and clean it, and then put it back onto the machine in order to have a continuous process. Then we go to the venturis, mixing the ambient air with the lubricant. And we have here the pressure monitoring, allowing the machine to know when is the best moment to switch from one line to the other. Finally, before exiting the machine, the lubricant goes through the flow sensor, making sure that we have the right amount of lubricant going through the pipes. We arrive in the press in one of those spray nozzles where we spray up and down to the upper punch and lower punch and the die. And we here have the vacuum up and down as well. And finally, we have the integrated vacuum, vacuuming of course the excess powder, the excess lubricant, which is sprayed by the nozzle. As seen before, the lubricant will enter the machine through the dosing hopper here. When we remove the safety cover, we can see that the hopper is here actually a soft silicone layer, which is shaken slightly on both sides in order to avoid rat holing and bridging. And at the bottom of the hopper, we have the dosing screw, combined with some slight vibration. So in this system, we use the volumetric system and not the gravimetric method, for the reason that, first of all, we have tested and proven that with the control of the screw speed and some slight vibration, we have some very constant and very accurate dosing. Also, there is no point to really concentrate on the dosing that much if you have no control of what's happening on the spray itself. If you spray very precisely, but you have no control about how well you vacuum the spray when it's not being used, then it means that you have a lot of lubricant entering the press anyway, and therefore have a chance to be mixed in the recirculation fingers. So in this case, we've concentrated our efforts also a lot on the vacuum. And therefore we have a very constant flow of powder going up and down, and the punch is going through that flow, and everything which is not being used is being vacuumed. Therefore, you have a very, very accurate dosing, and you have no excess of lubricant going into the press when it's not needed. So let's go more into the detail of what is happening into the venturi systems. So here we have some stainless steel 316L, into which we have the venturi, which is those two parts. And this is how we could represent them. So the venturi is only reduction of section here. Generating, this is here compressed air going through with speed, and this generates here a low pressure area. Here we have the dispensing in very precise quantity of the lubricants in this area here. And there is then a connection to this side of the venturi here, bringing the lubricants to the venturi. As I said, the air going through is accelerated here, and therefore we have under pressure, therefore we have also flow this way. And from this point on, we have a mixture of air and lubricant accelerated and going with force through those pipes here towards the spraying nozzle. So let's simulate the blockage of the venturi 1, for example. If I press on the pipe here, I will simulate that we have under pressure problem, and therefore we will measure it and switch to side B. It's easy to remove the venturi and go clean it. Then you put it back onto the machine, acknowledge that it's back on the machine, and you're ready to continue and switch back to line 1 if necessary. So this is the flow sensor. The purpose of the flow sensor is to make sure that we have a very stable flow of lubricants in the pipe at the very last moment before we go into the press. So how does it work? Shortly, we have a cavity here in the sensor. So the pipe is actually going through the sensor, not the powder directly. So here we have the pipe in which we have the mixture of air and lubricants, and is going with, of course, some speed and some force through the pipe inside the cavity, here, like that. So the friction of lubricant against the walls of the pipe is generating some energy, here and here. We simply measure that amount of energy here and here, and we will compare the two, and therefore we have an idea, and we can extrapolate how much powder, how much lubricant is going through the pipe, and most of all, its stability. One of the key elements, of course, of this design is the spray nozzle itself. Here, for example, we have a standard spray nozzle, which can be easily integrated in most presses just after the ejection finger and before the feeding shoe. This spray nozzle is, of course, a little bit more specific and is, as you can see, aerodynamic, as there was no part before and after, and we wanted to reduce the amount of drag in order not to have any lubricant deposits on the spray nozzle itself. And finally here, we can see our spray nozzle integrated into a part of a standard press. On this side, you would have the feeding shoe, so you can see there is not enough space to integrate our spray nozzle. And in order to integrate it anyway, we redesigned this part and we integrated the spray nozzle in this part to replace the part of the current press. Some more information about the under pressure system. So why integrate our own vacuum system? Well, in most cases, clients use their own vacuum system on site, which is used for the press, for the duster, and so on. But those vacuum systems make a lot of airflow, but not a very good under pressure. So when you install this kind of small diameter pipe, there is not a lot of air going through, and you do not control the spray inside the press. If you spray a little bit too much, most of it, which will be not vacuum in the vacuum system, it will just go in the press. By choosing this kind of vacuum system, which is using the venturi and not a motor with a turbine, we have 2 to 3 times more under pressure, meaning that we have a lot of airflow in this kind of small pipes, and we have a good balance between the spray and the vacuum at all times. The software that we have created for the iSpray is CFR 21 Part 11 compliant and very graphical, very easy to use. Here we have, for example, the display of what is happening on the machine and which sides we are using. We also have the state of the vacuum. Of course, we have user management with different users and different level of access. And last but not least, we have audit trail functionality with possible exports, reports. And finally, we have also customizable OPC UA communication to communicate with centralized systems or other presses or other systems. So thank you very much for watching this video. I hope you enjoyed it and that everything is now crystal clear. And if it isn't, never hesitate to contact us.